Hello and welcome to another episode in the series of doing simple GIS projects. So in this episode, we are going to look at a project where we are going to find out the number of structures that are within the radius of 500 meters or half a kilometer within a particular lake. So this project was actually contracted out by a client where he wanted to find out the number of structures that will be affected when a particular lake in Abuja overflows its bank. So this particular lake we are talking about is called the Jabi Lake. Jabi Lake is a lake that is located within Abuja, the Federal Capital Territory of Nigeria. And the project is to establish or count the number of structures that are within the radius of 500 meters from the lake boundary. So first thing first, we need to find the layers to work with in the QGIS environment. So I'm going to assume that I don't know the location of the lake. So to find out where the location is, I will need to go to Google Maps, then get the coordinate of the location, then search for it, and then establish the location within my QGIS environment. So let's switch to Google. So here I'm going to search for the name of the lake, which is called Jabi Lake. So hopefully this should take us to the Google Maps. So here we are on the search page. You will see Google Maps. So just click on the Google Maps and then let's open up where the map. So this will open up where the lake is on Google Maps. So this is the location. So one thing what we needed to find out here is to get the rough location and then access it on the QGIS, then vectorize the boundary. So what I'm going to do here is right click anywhere on the lake to copy the latitude and longitude location of the lake. So I'll copy it, then I will take it to a Notepad or a CSV file that I can easily open in QGIS. So what I'm going to do, I will just search for Notepad application and open it. Then inside it, I'm going to type my coordinates. So I'll just paste the coordinates like that. So when you copy a coordinate from Google Maps, the first is usually the latitude. So I'll just type in latitude. Then the second coordinate is the longitude. So this is how coordinates are arranged on Google Maps. So we start with latitude then longitude. So this is latitude, then this is longitude. So I can also add the name, maybe then on the coordinate line I'll add the name as Jabi Lake. So note that I separated every entity or variable with a comma. So name, comma, latitude, comma, longitude. So this is name, comma, latitude, comma, then the longitude. So had it been I have more record, I will just type in the other records in this format. So when I'm done with this, I need to save it as a CSV file, or I can just save it as a normal text file, and then I can load it in QGIS. But let me use a CSV file. So I will click on Save File, then Save As, then navigate to the location where my project folder is, and then save it there. So here is the location where I want to save it. So I'll just select all files here. Then I will give it a name, maybe jabilake.csv. So this will save it as a CSV file inside this project folder location. So I'll copy the path and then make use of it in QGIS. So I can now close this. So what I need to do is to go back to my QGIS, then go to add delimited text layer, then navigate to the location where I saved the Jabi Lake CSV file. So this is it. So I'll just select it. Let me enlarge it so that I can see the. So I'll just select the file and then click on open. And then the most important thing here is the coordinate system. So Google Maps coordinate system is based on WGS 84 with the EPSG code of 4326. So make sure you are using the correct coordinate system. Then you can see the preview of our data. And then make sure that the X field is always for longitude and then the Y field is for latitude. So we don't have a Z or M field here, so you leave it blank. So these are the most important things you need to take note of. And then after which you can now click on add. Then the layer will be added to the layer panel. You can close this window. So this is where the Jabi Lake is roughly. To verify this, we need to add a base map. So there are several ways of adding a base map. One of the easiest ones is to install a plugin called Quick Map Services. So I have done that, but let me just show you in case if you need to do that. So you go to plugins, then manage and install plugins. So from the dialog box that opens up, you search for Quick Map Services. So this is it. You select it, then you click on install. So in my own case, I've already installed the plugin. So in your own case here it should be installed. So you just click on install. In my own is asking me to upgrade, but I'm not going to upgrade it now. I'll use the version I have already. So in your own case, just click on install to install it. So that is one way of adding a base map to the QGIS environment. So after you have installed the plugin, then you can go to the web menu and then you will find that the plugin is there called Quick Map Services. Then you can now select the provider you want to use. So if you don't have this many options, you can go to settings. So from the settings, you go to more services and then you click on get contributed pack. So when you click on this button, you will have more options, just the way I have mine. So all these are the contributed packs that you are going to get. So just click on this button to get more of these service providers. So there are many of them, but I think Google is always on top. So I'm going to use the service provided by Google. But if you don't want to use that of Google, there are many options like OpenStreetMap is here, like USGS is there. We also have S3. You can make use of S3 boundary. I think I should make use of S3. Let me see if I can. If S3 has a satellite, yeah, they have the satellite option here. So let me just select S3 and make use of S3 here. So make sure that you are connected to the internet. So you can try S3 or Google, anyone that works for you. So this ESRI is they are the makers of ArcGIS software. So, but I think the Google image is more sharper than, it's more brighter than what we have with the S3. So I'll just maintain that of Google. So this is the lake. As you can see, this is our point located somewhere at the middle of the lake. So now that we have established the location of the Jabi Lake, so what we need to do, we need to digitize the boundary of this lake. So there are many ways to go about it. You can create a Polygon shapefile, then use it to trace out the boundary of the lake. But in this case, I'm not going to do that. I'm going to source for the polygon of this lake boundary. So I know that the data is available on OpenStreetMap. So I will just head up to OpenStreetMap and then download the Polygon shapefile. or I can even install another plugin that can help me download data from OpenStreetMap. But what I've done is I've already downloaded all the water bodies in the whole country using from OpenStreetMap, and I will also make it available for you to download in return for a token, if you don't mind supporting my channel or supporting my work. So let me load the layer and then continue with the work. So here I've loaded the layer. This layer is actually the entire water body in the whole country. So all the lakes and all the rivers in the country are captured. As you can see here, we have the lake chart, but our lake of interest is this one that is the Jabi lake. As you can see, our point is falling somewhere close to it, and as you can see that the shapefile is also overlapping correctly on the Google Map lake boundary. So what I need to do, since I'm only interested in just the Jabi lake, so I'm going to copy out uh, the polygon that makes up the Jabi lake. So I will select the layer, then select the lake polygon. So I'm going to export only the selected feature. I will export it to a shapefile, or I can use a geo package. Let me use geo package. Then browse to a location in my project folder and then save a copy of the lake. So here I am in my project folder, and then I'm going to call it Jabi Lake. Let me just call it Jabi Lake Polygon. Yeah, Jabi Lake Polygon. So I will save, then add it to the map. Yeah, so I can remove this entire lake layer. So now I'm left with just the Jabi Lake. So I think it is good if I can symbolize it. Let me double click, then change the symbols. Maybe the fill color. Let me make use of I think there should be a default water color here. Yeah, this blue fill. I think this one will stand out for color. Then the opacity, I'll take it to 50. Click on OK. Yeah. So this is our lake. So this layer 2, I think this layer we are also done with it. We don't need it anymore. It is only to guide us to locate the approximate location of the lake, and it has done the purpose. So we remove it so that we have a cleaner layer panel. So the next thing we need to do is remember that the task is to get all of these properties, to select all of these properties that are within 500 meters from the boundary of the lake. So maybe there is possibly there is a forecast that there's going to be a heavy downpour and the lake is going to overflow its boundary. So all the properties that are within 300 meters will be affected. So we are given the job to find out the number of properties that are within 500 meters so that the authority can plan emergency response, or can plan for evacuation of those occupants of those properties effectively. So that is what we are trying to establish in this project. So now that we have established the location of the lake, and then we have digitized the boundary of the lake into a polygon, the next thing we need to do is we can buffer this polygon by the given distance, and the given distance here is 500 meters. That is 0.5 kilometer from the boundary of the lake. So I can use my measure tool. So measure line. Let's see how far 0.5 kilometer is from the boundary. So let's assume from this boundary, we click and then we measure. So 0.5 should be somewhere here. So this is somewhere here. So somewhere here is 0.5, as you can see. From here, 0.5 should be somewhere here. Yeah, as you can see. So the whole of these properties are within half a kilometer or 500 meters from the boundary of the lake, and we need to find out how many they are and count them, and for the authority to be able to plan its evacuation or plan its emergency response. So to proceed with the project, we need to convert this polygon. This is a polygon. We need to convert it to a line so that I can offset the line at 500 meters. So what I need to do first of all is convert this to a line and then offset it to 500 meters. So to do the conversion, I'm going to use a tool in the processing toolbox. So I'm going to open up the processing toolbox and then search for tool that converts polygon to line. So polygon to line. Yeah, this is it. And then you can find it under vector geometry. This is polygons to line. So as you can see from the description, it converts polygons to line. It's as simple as that. So we only have one polygon in our input layer, which is the Jabi Lake polygon. And take note of the coordinate system we're using. The coordinate system is in degrees. We're using the 4326, that is WGS 84 coordinate system, which is in degrees, not in meters. So take note of that. Ideally, we would have used a projected coordinate system that will allow us to measure, to make measurement in meters, or make measurements in linear measurement, such as meters, kilometers, and so on. But even if you are using a coordinate system that has its units in degrees, you can still make use of linear measurement, because there is a conversion factor between degrees and then kilometers or meters. And I'm going to show you a table where you can find a conversion factor. So just in case if you don't know it, but for now, let's convert this to line. So we are converting the polygon to line. So I'm going to save it in my project folder. So here I'll just call it maybe Jabi Lake. Let me just call it lines. So that is all I need to do. Then I click on run. So it will run. Then I close. And then you can see that it has generated the equivalent line boundary. So let me just increase the thickness of the line, and maybe I will change it to this yellowish color. So this is the line, while this is the polygon. So the polygon is there, the line is there. So what we need to make use of is the line, not the polygon. So after converting it to line, I will use the processing toolbox to find another tool called offset. So offset, so this is it, offset lines. So this tool will offset the line to a particular distance we gave it. So as you can see, the input layer, it only accepts line layers. So we can only select the line layer we generated earlier. So and then note that the degrees, the layer is in degrees. The unit of this layer is in degrees, which is 4326. EPSG code 4326 represents WGS 84, which has its unit in degrees. So, but we cannot give the unit in degrees. If you just type 0.5 kilometer, the layer will interpret it as a degree, not in kilometer. Or if you just type in 500 meters, the layer will interpret it in degrees, will interpret it as 500 degrees, not 500 meters. So we need to find the equivalent of 500 meters or 0.5 kilometer in degrees. So let me show you the table I was talking about earlier on, and then you will see how it is done. So here on this website, we have the approximate metric equivalent of degrees, minutes, and seconds. So I don't know why my browser is not reading this symbol correctly, but this symbol stands is the degree symbol. So this is supposed to be 1 degree. So this is degree. Just take note of that. Maybe if you open up the website, I'm going to leave this address in the video description. So maybe if you open it up, your browser should be able to interpret this degree symbol correctly. So 1 degree is equivalent to 111 kilometer or 60 nautical miles. Then 0.1 degrees is equivalent to 11.1 kilometer, and so on. 1 minute is equivalent to 1.85 kilometer. Then 30 seconds is equivalent to 900 meters. So this is the conversion factor. So I'm going to use this. The approximate equivalent of 1 degree is 111 kilometer. In order for us to get the equivalent degree of 0.5 kilometer, we'll just do cross multiplication and then divide 0.5 by 11, by 111 to get the equivalent distance in degrees. So let me use my calculator to do that. So just in case you are confused with the calculation I'm talking about, let me clarify it by filling it out in the Notepad. So here's what I'm talking about. 1 degree. 1 degree is equals to 111 kilometer. So now we need to find the equivalent of degree of 0.5 kilometer, and 0.5 is equivalent to 500 meters. This is the same thing as 500 meters. 500 meters is the same thing as 5 kilometers. So we want to find the equivalent of this in degrees so that we can make use of it in QGIS. So this will simply means that when you multiply this by this, you have 111x, and then this by this you have 0.5. So 0.5 divided by 111 will give us the equivalent value in degrees. So that is 0.5 divided by 111. That should give us 0.0045. So this x will be 0.00 degrees. So this is exactly what we need to enter in QGIS. So I can minimize this and go back to the QGIS environment. So here, for us to have 500 meters or 0.5 kilometers, the value here will be 0.0045. That is the degree equivalent of that distance. Then the segment, all these, we can leave them at the default, but you can give it a try. If you can change the values and play around with it and see how they affect your work. But the defaults are okay at the moment. So I'm going to save it to my project folder as usual. So here I'll just call it Jabi Lake offset, maybe offset line. So click on save, then I will run the algorithm. So the algorithm has run successfully. I'll close it, and then I will zoom to layer, and then as you can see, let me change the symbology so that you can see it better. So I'll just change it to this red line, apply, okay. So as you can see, this is the, let me close this window so that we have enough space. So as you can see, this is the offset from the boundary. So the whole of this portion that is within the, that is inside the red line are those places that are 500 meters or 0.5 kilometer from the lake boundary. So with this now, we need to find out how many structures are within this boundary. So to do that, what I need to do next is to create a point layer. I'll create a point layer and then digitize the entire properties. So of course, you are not going to count the properties on the screen like this, because if you try to do that, definitely you run into issues and you get lost. But if you use a vector layer to just digitize, you don't even care. You shouldn't worry about counting the points as you're digitizing. When you are done, you only get to count the number of points you have in the layer, and that will give you the number of properties that are within the buffer or the offset distance. So let's do that. I will go to layer, then I'll create a new layer. So let me create, I'll create a new GeoPackage layer, or I can create a new shapefile layer, anyone. So let me just create a new shapefile layer. I'll just click on the shapefile layer, then browse to the location of my project folder. So here I'll just call it Jabi, maybe properties, Jabi Lake properties, or Jabi Lake affected properties. Click on OK. So it's going to be a point layer. And then the coordinate system, I'll just make it WGS 84. Then I don't think I need to put any field. So, but I can have the integer field, just the ID field. I don't think I need any name. I don't need any attribute field at the moment. So I'll just leave the default one and then click on OK. So I'll now start editing. I'll pick my point, then I'll start digitizing the properties. So usually you digitize one property at a time. Click. So usually you see that different you identify properties by, you can do it by the buildings, or you can do it by the boundaries of the plots. Like from here to here, it should be one property. Then this is one, this is another one, this is another one, this is another one, this is another one. All these are other properties because they are in the same fence. And this one is another property. This one is another property. So depending on how a property is defined, maybe is it the building that makes up the property, or is it the land that makes up the property? So depending on how the specification is for your project, then you count, you click to digitize each one. So here I'm just using the land, not the buildings. So the whole of this should be one property. This another one, this another one, because they are in different land boundaries. This is another one. So this is another property. So the whole of this should be also another compound. This is another one. So this is how you continue until you cover the entire area. So at the end of the day, by the time you open up the attribute field, the attribute table, you'll find out you'll find the total number of the properties you have digitized, and that will give you the total count of the properties that will be affected in 500 meters offset distance from the lake. So this is how the project is going to be completed, and I hope you understood the concept and you will take your time to actually do it to get acquainted with the process. So thank you for watching and then have a nice day.